In last video, we have discussed about the shape of orbitals S, P, D and F. S orbital is spherically symmetrical, P orbital is dumbbell shape, and D orbital has a three-dimensional structure which is double dumbbell shape. Now in this video, we are going to discuss shells, subshells, orbitals, then some rules governing the electronic configuration, that is above principle, Pauli's exclusion principle and Hund's rule of maximum multiplicity. Now electrons are revolving around the nucleus in a particular orbit or shell, and shell, it is designated by principal quantum number. When n is equal to 1, then it is K shell. When n is equal to 2, then it is L shell, and when n is equal to 3, then it is M shell. In shell there are n number of subshells. For example, if n is equal to 1, there is only one subshell. That subshell, it is 1s. When n is equal to 2, there are two subshells, that is 2s, 2p. And when n is equal to 3, there are three subshells, 3s, 3p and 3d. In subshell there are orbitals. In 1s subshell there is only one orbital, that is 1s. In 2s subshell there is also only one orbital, that is 2s. And in 2p subshell there are 3p orbitals, that is 2px, 2py, 2pz. Similarly, in 3s subshell there is a one orbital, that is 3s. In 3p subshell 3p orbitals are there, 3px, 3py, 3pz. And in 3d subshell there are 5 d orbitals, 3d xy, yz, zx, dx square minus y square and dz square. And electrons are actually present in the orbitals. As an example, you consider an electron is in 4f subshell. What are the possible values of quantum numbers? As electron is present in 4f subshell, this number 4, it is the principal quantum number, and therefore n is equal to 4. And as it is present in f subshell, for f subshell, azimuthal quantum number is 3. If L is equal to 0, then S, L is equal to 1, then P, L is equal to 2, then D subshell, and for F subshell, L is equal to 3. And therefore, for 4f subshell, n is equal to 4, L is equal to 3. Now there are 7 f orbitals, and each f orbital, it is designated by magnetic quantum number, and 7 possible m values are -3, -2, -1, 0, +1, +2, +3. And in a particular orbital, 2 electrons are possible, one with clockwise spin and other with anti-clockwise spin. For clockwise spinning electron, S is equal to +½ whereas the electron which is spinning in anti-clockwise direction, S has -½ value. So these are the all possible values of quantum numbers. Another example, what is the designation of orbital subshell having number 1 n is equal to 2, L is equal to 1, second n is equal to 3, L is equal to 0, then n is equal to 5, L is equal to 3, and n is equal to 4, L is equal to 2. So these are the 4 different subshells. Now when n is equal to 2 and L is equal to 1, then the subshell must be 2p. For n is equal to 3, L is equal to 0, L is equal to 0 means S. The subshell must be 3s. When n is equal to 5 and L is equal to 3, the subshell must be 5f. And when n is equal to 4 and L is equal to 2, then it must be 4d. This is the answer. 2p, 3s, 4, 5f and 4d. Now next point is electronic configuration of elements. The distribution of electrons in a various shells, subshells and orbitals in an atom, it is called as electronic configuration. And this is the general representation of electronic configuration. NLX, where n is a principal quantum number, L is azimuthal quantum number indicates the subshell, and this X, it is the number of electrons present. For example, if electronic configuration is 2p2, then this 2, it is a principal quantum number. It indicates the energy level of electron. P, it stands for the subshell or sub energy level, and this number 2, it is the number of electrons. So this electronic configuration, it is governed by these three rules: above principle, Pauli's exclusion principle, and Hund's rule of maximum multiplicity. Now first of all, what is the above principle? Above, it is a German word. Meaning of this is building up. And according to above principle, in ground state of an atom, orbitals are filled with electrons in order of increasing energy. It means lower orbital is filled first. For example, in a particular atom, suppose there is only one electron, for example hydrogen, then that electron prefers to accommodate in lowest energy orbital, that is 1s orbital. If there are 3 electrons, then accordingly electrons are filled step by step. Next electron, again it prefer the lowest energy. When lowest energy orbital is filled, then next electron enter in next higher energy orbital. The energy of an orbital increases with increasing value of n. This is very important. When n is equal to 1, then orbital or that particular shell is having lowest energy, as compared to n is equal to 2, 3, 4, 5. So energy of shell increases with increasing value of n. Now orbitals are filled in order of increasing value of n plus L. N plus L. N is principal quantum number, L is azimuthal quantum number. And if two orbitals have same value of n plus L, then the orbital with lower value of n will be filled first because it has the lower energy. And this is the above principle, above order. According to above principle, 1s orbital has lowest energy, then 2s, 2p, 3s, 3p, and so on. So in this way, energy increases from 1s, 2s, 2p, 3s, 3p, 4s, 4d, like that. Now how this above order is there, that we are going to discuss here. Now consider four orbitals, s, p, d, and f. First of all, you consider s orbital or s subshell and write this s subshell 2 times, s. Now consider next set ps. Write ps 2 times, ps and ps. Now consider dps. Write dps 2 times, dps and dps. Now next is fdps. Write fdps and fdps 2 times. Now first of all, you number the s orbitals or s subshells. So this is the first s subshell, and s subshell starts from first shell. So this is the principal quantum number. This is 1, 2, 3. Remember, only we are numbering the s orbitals. So this is 3, this is 4, 5, 6, this is 7, and this is 8. Now you number the p subshells. Now p orbital or p subshell starts from second shell. So this is second, third, this is fourth, this is fifth, sixth, and this is seventh. Now number the d subshells. So d subshell starts from third shell, 3, this is 4, this is 5, and this is 6. And now number the f subshells. F subshell starts from fourth shell. So this is 4 and this is 5. And this is the above order. So energy increases like this: 4s, 3d, 4p, like this. 5p. So here 1s orbital or a subshell has lowest energy, whereas energy increases in this order, 1s, 2s, 2p, 3s, like that, and here 8s orbital or a subshell has highest energy. Now we'll apply the above rules. Now for 1s orbital, apply n plus L rule. Now value of n is 1, L is 0. So 1 by 1 plus 0, that is 1. So sum of n plus L value is 1. It has the lowest energy. Now for 2s orbital, according to n plus L rule, so 2 plus 0, that is 2. Here 2 plus 1, that is 3. Now first of all, you compare electrons filling in 1s, 2s and 2p orbital. Electron prefer the 1s orbital because it has lowest n plus L value. After filling 1s orbital, then it prefers the 2s orbital because it has slightly higher energy, because n plus L value is 2, and then 2p orbital, it has higher n plus L value. This is also 3 plus 0, that is 3. So now these two orbitals have same n plus L value, but out of these two orbitals, 2p orbital has lower n value, and therefore 2p orbital is filled first before entering electron in 3s orbital. Similarly, for 3p orbital, 3 plus 1, that is 4. For 4s, 4 plus 0, that is 4. So two orbitals have same n plus L value, but 3p orbital is having lower n value, therefore electron enter in 3p orbital first before 4s orbital. For 3d orbital, 5, 4p orbital also 4 plus 1, 5, 5s orbital, 5 plus 0, that is 5. These three orbitals have same n plus L value, but electron enter in 3d orbital because principal quantum number or n value increases in this direction, 3, 4, 5. So 4d orbital 6, then here 5p 6, then for 6s orbital again n plus L value is 6, but for 4d orbital n value is lower, and therefore electron enter here first, and then 5p, then 6s. Similarly, for 4f orbital, n plus L values are 4 plus 3, that is 7. For 5d, 5 plus 2, that is 7. For 6p, 6 plus 1, that is 7. And for 7s, 7 plus 0, that is 7. These four orbitals have same n plus L value, but n value increases like this, 4, 5, 6, 7. So electron enter in 4f before entering the 5d, and accordingly orbitals are filled. For 5f orbital, n plus L value is 5 plus 3, that is 8. For 6d, again 6 plus 2, that is 8. For 7p, 7 plus 1, that is 8. And for 8s, that is 8 plus 0, that is 8. So these four orbitals have same n plus L value, but n value increases in this order, 5, 6, 7, 8. And therefore first of all electron enter in 5f orbital, then 6d, then 7p, and then 8s. So this is the above order. Here 1s orbital has lowest n plus L value, that is 1, and 8s orbital is having highest n plus L value, that is 8, and accordingly electrons are accommodated in these orbitals. So this is the first rule, that is above principle or above order. So in next video we are going to discuss the Pauli's exclusion principle and Hund's rule of maximum multiplication.